Welcome to NTWC Live. I'm Alex Garcia, Director of the National Tropical Weather Conference. These programs are made possible by USAA, by South Padre Island Convention and Visitors Bureau, and Plylock's Hurricane Clips. All of these programs are a team effort. We have Bill Reed and Tim Smith with us to make these possible. And now, here's Tim Smith, live at South Padre Island.
Good afternoon, everybody. Welcome to NTWC Live. Today's broadcast is going to be an exciting one with Ken Graham from the National Hurricane Center. I am on beautiful South Padre Island. I'm at Jim's Pier. For those of you that know South Padre Island, right next to me is the Painted Marlin Grill, one of our dine-around restaurants at the National Tropical Weather Conference. So if you've been to the conference, you've probably had dinner at that very restaurant, one of many bayfront restaurants here. Of course, South Padre Island, one of the hosts, the host, and one of the sponsors of the National Tropical Weather Conference, and they wanted me to tell you that they are open. And I was here this past weekend, and boy, are they open. There's a lot of folks here, and most are doing a good job of social distancing, but the weather's been beautiful, so folks are coming out to enjoy South Padre Island. Bill Reed, I got to point out, you can't see it, but right next to me, there's this beautiful, probably about a 30-foot fishing boat, and right on the side, it's got the great big Texas A&M logo. Bill?
All right. Count me in. I'm up for some snapper. Good morning, everybody. Since we last met a week ago, we've birthed and buried the first named storm in the tropical Atlantic. That was Tropical Storm Arthur that did a brush by the coastal North Carolina region before going out to sea. Also, earlier this morning, Cyclone Amphan made a landfall West Bengal, which is extreme eastern India. It was just south of the major metropolitan area of Kolkata, which we all know as Calcutta in the past, and is currently about 40 miles to the northeast of that city. There's roughly 30 million people live in the coastal zone where that 85-knot storm made landfall, and the Indian Meteorological Department had forecasted 4 to 5 meters of storm surge there. So I think we'll see a lot of damage. We hope the people got to their shelters in time. Okay, today we have the honor of having the director of the National Hurricane Center, Ken Graham. Ken was promoted into that position several years ago after leading the New Orleans Baton Rouge office through a multitude of disasters, including the Deepwater Horizon oil rig disaster, Hurricanes Gustav, Ike, and Isaac. Before he started his career in the Weather Service, he managed to get degrees from out west at Arizona State and at Mississippi State, where he did a little broadcasting before coming to the Weather Service. He's had many management jobs in his career in the Weather Service, all of which have helped prepare him for the unique challenges that come up the National Hurricane Center. He had Dorian and Imelda last year, and he had Michael and Florence before, so he's been well baptized into the new job. So Ken, what's happening in your world now?
I'll tell you, Bill, thanks for that introduction. It's great seeing you. And Alex and Tim, thanks for having me on this show. It's just absolutely amazing to be here. But yeah, think about it. My 2 years here, this is my third season. Florence, Michael, Dorian, and lots of others. It's been a busy couple years, and it looks like the official NOAA forecast coming out here soon. Everybody's seen the other forecast, looking at another busy season. So it's going to be continuing to be busy, Bill. So we're going to move on to the presentation today, it looks like. I wanted to give a shout out to Dan Brown. Dan Brown's our warning coordination meteorologist here at the National Hurricane Center. Through the miracle of technology, Dan will be sharing his screen and running the slides as I get to be here in my office. Bill, you recognize this office. You were here, and you can see the hurricane shutters I've got shut just to keep the light out. But anyway, we've got the shutters down here. But wanted to get into a different presentation today. Again, thanks for having me on. And it was interesting looking at this season, and I don't know why. I guess the older I get, the more reflective I get. I start looking at the past and start looking at, different storms. We always talk about you can't compare storms, but there's sure lessons. I mean, you look back at the last 27 years working in so many different tropical systems. I mean, what I did was I jotted down my top 10 lessons learned over the years. So that's what I wanted to get through today and talk about some of these things. I think some are recent, some go way back, some are more well known than others. So we're going to get to it here. It's pretty interesting. I did want to show you behind the scenes have a hurricane wall. I mean, this is something a lot of you see in the past. You've been able to see some of the tracks, and it was only about a month ago. We still had last year up on here, the magnets and all the different storms in the Atlantic and the Pacific. But the next slide, I will show you that we have cleared the slate. There's Arthur. We've got that on there. So we got some of we put the names on there for the Pacific and also the Atlantic. You can see the Atlantic names there. So the board's clear, and we're going to be adding some storms this year. But for last year on the next slide, you'll see it was an active season. We've had active seasons the few years I've been here so far. I mean, 18 named storms in 2019, 6 of those hurricanes, 3 major ones. So you can see the tracks right there in the Atlantic, quite a few of them. Dorian, of course, the Category 5, producing catastrophic wind and water damage throughout the Bahamas. But there were some others as well that we're going to look at. But remember, here at the Hurricane Center, it's not just the Atlantic. Our coverage area goes from the African coast, European coast, and on the next slide, you'll see we cover all the way to 140 degrees west. We go well out into the Pacific as well. So that's a large area that we're covering across the globe, watching for tropical systems and also marine forecasting as well. So let's get into some of this. Let's go on to the next slide. Lesson number 1. Over the years, and this is, I don't know, it's becoming more of maybe a pet peeve than maybe it should for me, but there's no such thing as a fish storm. Here at the Hurricane Center, I just covered how large of an area that we do cover. All the countries through the World Meteorological Organization, we work with the countries to coordinate the forecast. They issue their watches and warnings based on that forecast. So it's a constant communication. There's ships out there, there's countries. They're impacted by these storms, even if it doesn't reach the continental United States. We still have territories, we still have other nations that we look at. Here's a great example of a typical hurricane that would be moving through the Caribbean, headed westward. You can see all the coordination of watches and warnings that take place. There's no such thing as a fish storm. They're still busy for us. On the next one, I think it's interesting to look at this question. This is one that, Dan, you and I were talking about, and it's one that's really important. Behind Dorian, we know the history of Dorian. We know the devastation to the Bahamas. But in 2019, in the Atlantic Basin, which named storm was the second deadliest of the season? So we have Andrea crossed out there. We have Dorian circled because we already covered that. So we're looking for number 2. So the next slide, we're going to cross some of these things out. You'll be able to see we didn't get to past Sebastian, so those don't count. The next slide, you'll see some others that we cross out. It was Lorenzo. And looking at the next slide, you'll see why this is. So let's look at it a little closer. So wait a minute now. You look at this going, well, Lorenzo, look how far this was offshore. I mean, it's pretty much between the U.S. and Africa. So how could this be? Well, it's interesting. 11 offshore deaths due to the sinking of the Bourbon Road. 3 crewmen were rescued. NOAA playing a big part in that rescue with the Tropical Analysis Forecast Branch here at NHC providing some spot forecasts for those areas. In other words, latitude, longitude forecasts, and the NOAA hurricane hunters performing some search and rescue operations to help rescue those crewmen. But here's the thing. On the next one, you put some dots on the map. 8 rip current deaths in the United States from Florida to Rhode Island. So here's a storm well out in the Atlantic that's so strong, pushing out waves, pushing out swells that can reach the U.S. and cause fatalities all the way across the ocean. For us, there's no such thing as a fish storm. So we definitely wanted to bring that up. Here's some of the work that takes place, working with Coast Guard, working with the French Navy and search and rescue. The NOAA hurricane hunters were able to help out. And also our crew here at the Hurricane Center. A lot of times people are like, Ken, what do you guys do when there's no hurricane? A lot. Here's a case that we support during a hurricane, but even year-round, the TAFB, the Tropical Analysis Forecast Branch, provides spot forecasts, wind and waves, swells. They're constantly watching the oceans to put out that forecast. You'll see on the next one really what I'm talking about, how we keep the offshore safe. We always see the map with the aircraft, all the aircraft in the sky. Well, this is ships. I mean, look at all these ships at any given time. Lots of people. There's oil rigs. There's ships all over the oceans. The next slide really tries to show you what we try to do. So on the left is ship traffic before Dorian. On the right, on the next slide, that's avoidance. They're getting out of the way. So our job is to make sure we get these ships out of the way. You can clearly see what happens there. So moving on to the next slide. And Dan, I definitely appreciate you running the show here. Look at some of the comments back. I mean, you could just see them pop in. Spot forecast received. They're getting the information that they need for a search and rescue. It really helps out. And that is year round. Look at all of them. There were so many of them just last year alone. Each one of those little geographic symbols there is a spot forecast issued by TAFB. So kudos to them, and appreciate all of that work. So that worked out perfect. So that was lesson 1. No such thing as a fish storm. Lesson 2. Be careful looking at your favorite model. I mean, I think some people watching today have maybe heard me say some of this before, but I think it's really important that we review it again. Look, here's some quotes that I always hear. And Bill, I know you've heard these too. I think we've all heard these. How about this? Oh yes, all those lines miss me. Well, we're good. Or, oh no, one of those lines hits me in 10 days. Or this model was best last time. Those are common quotes that we hear. So let's take a look at this real quick as lesson 2. I think it's interesting to be able to look at. So here's some data. Incredible leaps in track forecasting over the years. A real true scientific success. So if you look at this graph, the steeper the slope, the more trouble with the forecast, the worse the track forecasting is. You can see through the decades, 60s, 70s, 80s, 90s, 2000s, 2010s. It's incredible how far we've come when it really looks at the forecast for track. This is the track forecast period going out through time. Unbelievable improvements in the track. So we're getting better and better, and I think that reflects in our forecast. The next one, I mean, the computing power is getting stronger, but the point I want to make with lesson 2 is if you compare the National Hurricane Center with the global models, by the way, we do it here for 2017 and 2018. You could go back decades and you can see the same consistency with this. That we're more skillful. The National Hurricane Center forecast is more skillful than any of the models. And so if you look at the actual chart here, the black line is the NHC forecast. It's better than the models. You'll have some crossings every once in a while. It usually has to do with a troublesome storm that's a little more difficult to forecast. But if you think about it, we're beating the models. The next one, you'll see, even looking at 2019, last year, what we were neck and neck with the European model at the beginning. You can see the very beginning, days 1 and 2, very, very close. But then NHC is more skillful days 3, 4, and 5. So if you take 17 through 19, on the right slide there, the right one, you can see we're beating the models every single time. And I think this is really important because, especially you start going further out in time, we start looking at all the spaghetti plots, as you'll see coming up on some of these graphs. We're beating the models. So I think that's a good takeaway. You have an official forecast. We're putting that forecast out. We're going to look at the next one, Dan. And I think this is an important one too. This deals with the quote that I had up there about, well, this model was good last time. This is the model I use. It depends on the storm. You actually go look at the data and look at the models, how they perform in each given storm. It varies. It varies storm to storm. Sometimes you'll have one model good in this storm, and then the next one it's not as good. This is a really important point because in each given storm, you can't just say this model always performs the best, I'm going to use this one. It actually varies depending on the storm. So we go to the next one. What's the takeaway here? I think it's an important one. We always hear about the spaghetti plots and that sort of thing. They're all over. We're always going to find the one line that gets close to us if we're one of those that are ready to act. And if one of those that are optimistic, you'll find the one line that doesn't reach us. Look, we got 170 years of combined experience here at NHC. Real proud of that. And, our forecast beats the models every single time. We've got you covered. We're working it. We've got the errors built in with the cone. That's what we're here for. So that's a takeaway there. Otherwise, I tell you, finding every single line that hits you eventually makes it a very stressful hurricane season. So the next one, we'll go on to some of the data. I talked about the forecast getting better when we start looking at the actual forecast error with track. Look over time. I mean, it's interesting to watch the slope downward. You want that downward slope headed towards the right side of the slide here. That means the forecast track's getting better. In 2019, you're going to have some bounces. 24 and 48-hour track slightly up in 2019. There's usually a few storms that cause that, but overall, we have a trend that keeps getting better, and that's exactly what we want. And it's an interesting thing to really look at with these models. Even if you get the little bounces, you're getting better with time. And look at the extended. You still look at it, that 120-hour forecast, and look how much progress has been done in the extended forecast. That's pretty impressive. So track is getting pretty good. The next one. Appreciate you, Dan, keeping up here with all this. So let's look at last year. One thing about the Hurricane Center is interesting. We will share what we're doing well, and we'll share places that aren't going so well. We're very open with all the data. We got nothing to hide, and we really like to share it because we get feedback and we get research that gets back into this operation to make the forecast better. But we start off really, really good. I mean, look at this, a good start to it. You had a 5-year average there. The red lines, the lower, the better. The less error, that's what we want. And, Aaron and, Gabrielle was a little bit above the 5-year average. So we start off pretty good. I mean, that's a great track record there. But look what happens towards the end. It's interesting when you get these late season high latitude storms that the models really struggle with. Look what happened with Pablo and Sebastian, large errors. And that's associated with just being somewhat of a hybrid, high latitude. The model struggled with it. So that's going to skew all the data for the year. So just very open with how hard some of these storms are to forecast. So next one. We'll see this. I think this is interesting to look at. This is, it's a forecast success. This was Hurricane Florence, a few years back. And if you look at all the Hurricane Center forecasts, the models were on it. We were on it. Just absolutely not a lot of error associated with the track forecast in Florence. These are your 5-day forecasts. And the next one's interesting. And when you look out, this is back to the cautionary trail. The white line with the dots, that's our forecast. But if you look at the blue lines there, the ones that recurve, those are the 6- and 7-day forecasts based on the models. So we're able to sort through that and actually correct for those type of things. But when you start using the raw models, these are the type of things that make it very difficult, especially in the extended period. And why this is important? Well, 6 or 7 days out, if you're going into a holiday weekend and you see that recurvature, you may have a false sense of security with something like that when indeed Florence came on in. So that's something that's always a big lesson when it comes to the modeling. Okay, we're going to look at the next one. You can see some of the points I'm trying to make. And in the end, I guess the question becomes, I always like to ask, why does it matter? Well, it matters because the better we can do with the track forecast, the better we can do help with the decision makers. This is your 3-day forecast cone in 1990, and the next slide you're going to see the updated one. This goes back a few years, and we keep getting it smaller and smaller every year. That's the 2018 cone. So the better we can do with the track forecast, the smaller the cone. And think about it, 3 days out, if we can have fewer people that have to take massive actions, that's better. That's a better process, and that helps people out. So the smaller the cone, that's what we want. But we'll get into it here in a little bit. The smaller the cone, the more impacts outside that cone. But that's another lesson coming up, a little teaser there. Okay, so the next one. Let's get into the next lesson. Lesson 3. This is it. It's all about the impacts. I've been one that constantly talks about this. I know the Hurricane Center here for at least a decade or more has really spent a lot of time to say it's about the impacts. It's not necessarily just about that, about the forecast track. And I just give you some examples here. It's all about the impacts. So what I have here is a good way to show it. So if you look at the forecast cone, the left one, there's your cone. You can picture a track right there in the middle. Look at the size of the storm. It's well outside that center. It's well outside the cone. And on the right side, same thing, the wind field. If you look at the wind field there, that's depicted in the orange little blob all over Florida, stretching up into Georgia and South Carolina. That's the wind. And that wind is well outside that cone. And we start looking at the next slide. There's so many examples. I really could come up with slide upon slide. So I just tried to pick some of the main impacts. The left one here is the storm surge. So look at the storm surge values on the east coast of Florida, going up to Georgia and also South Carolina. Look how far away from that cone. And this is an important fact because that's reflective of the wind field. When the wind field is at large, you get that onshore flow and get some of that storm surge. So what an important point that we have to make here. And on the right side, that's your rainfall. And you see the track there versus where the rainfall is, and a lot of it, once again, is well away from the track. So what a lesson. This is about the impacts, not necessarily just about that cone, not necessarily just about the forecast, but it truly is about the impacts. And the weather forecast offices along the coast have graphics. These are important. Everybody watching, these are all on the websites of the forecast offices use these things. That's what they're there for. You can use them in your briefings. You can use them in your planning. It takes every different one of these impacts and starts looking at the threat of each. And I think that's something that everybody could use. So that's one that I definitely wanted to highlight here. You can look at the impact. You can look at how great of a threat that is. So lots of impacts, and we have lots of ways to be able to show people these things. So let's look at something. I think this is an interesting one. Dan put this together. We've had a lot of discussion on this next group of slides. So here's your 5-day error. Let's say there's a hurricane headed our way. So you have the 5-day, there's your 4-day cone. You start narrowing it down in 3 days. There's your 3-day cone. And the next one, you got your 2-day cone. And the next one, 1 day out, you'll start getting your 1-day cone. So you get smaller and smaller as we get closer in. So, but let's look at how this matters, because here's a typical, let's take this storm here. This is a 2-day cone, and you run it. Remember, the cone is where the actual center of the storm could be 2/3 of the time. Well, that leaves 1/3 of the time outside the cone. So 2/3 of the time, that center could be anywhere in there. So let's just say the center moves well left, right on the edge of the cone. And that's this first example here. So what happens then? Well, everybody gets different impacts if you think about it. So you think about what happens to the right-hand side, you think about on the left-hand side, different impacts. Let's go through these, Dan, and we'll be able to explain them. So let's think about a storm that runs right in the middle. Now all of a sudden your impacts of storm surge, that shifts too. These small movements of this storm can make big differences on the ground. And I've seen examples, I think Irma's one of them, that 30 or 40 miles makes the difference in 2 foot of storm surge versus about 10 foot of storm surge on the west coast of Florida. And here's your other example. You start getting on the other side. Remember, and the next one, Dan's got the 3 X's that I put on here. Your impacts at each one of these locations changes greatly with these small shifts in the storm. These are all within the error. All of these forecasts are not too bad if you look at any one of these forecasts, but the actual impacts to these points that I point out, and lots of them, right? There's hundreds, if not thousands of X's, because every point has a different impact. So if you go further on the right side, that's more storm surge, that's more wind up there in the Outer Banks of the Carolinas. If you get further off to the left, that's more impacts for the X there in Georgia. And by the way, that X inland, the reason I put that one there is just because you're not on the coast doesn't mean you won't see the big impacts. There could be wind, there could be rainfall, and a lot of flooding, even that X right there on the South Carolina, North Carolina border. So that's an important one to remember, because after every storm, everybody has a different perception of what happened. But we have to get the information out there that small changes make a big difference on the ground, and that's why the preparedness part of this is so incredibly important. So wanted to make that point on this one. And there's the storm continuing to move in different directions. So takeaway here. Here's a takeaway. This is an important one. So it's all about the impacts. Here's proof. Category 5, Category 4, yes, absolutely devastating. But look at the data here. Since 2010 in the United States, Cat 1 hurricanes have caused 175 direct deaths and $105 billion worth of damage. In other words, it doesn't have to be those big storms. It could be a tropical storm. And Bill, you and I have talked about it. There's no such thing as just a tropical storm, just a Cat 1. Look, it's about the impacts. Listen to those. A slow tropical storm can produce devastating rainfall. Even a slow Category 1, a large one, can produce a lot of storm surge. I've seen, you go back to Hurricane Isaac, very large storm, but because moving so slow, you got a 10 to 12 foot storm surge out of a Cat 1. See what I'm saying? So size matters, direction matters, speed matters. There a lot goes into this besides the actual category. So this is one to remember for everybody. So hopefully that helps with that lesson there. So lesson 4. Wow, social science matters. This is one near and dear to me. I always like to say, and I think others have said it too, a perfect forecast is fine, but if it's not understood and actionable, then there's still a failure here, right? We have to be able to communicate. We have to communicate in ways that people understand. And we've done some things about it. These are new graphics. This one here is one of the examples of, when are the winds going to be getting here? I mean, that's one of the most common questions we get before the storms. When's it going to get here? Well, then we listen to that, and we work with social scientists and physical scientists to put together graphics. And this one here is the actual timing and when you can expect those tropical storm force winds. Why does that matter? Well, when those winds arrive, it's too dangerous to be holding plywood outside. It's too dangerous to be up on your roof preparing or trying to board up or do whatever preparations that you have. If there's tropical storm force winds, it's too dangerous to be outside. So we try to give everyone an idea when those winds are going to arrive. And look, this takes into account the track, the size, the intensity, all those uncertainties are built into this so it doesn't change too much with the forecast time. So let's look at a few more of these because this is an important topic to me, getting these together. Also, so much work went into the storm surge forecasting. Remember, I talked about it's about the impacts, not necessarily about the category. And the storm surge, causing historically half the fatalities in these tropical systems. These graphics right here, social scientists, physical scientists, the people that make the decisions, all sitting around the table, figuring out how do we put a graphic together that's well understood. And this is an example of the storm surge watch and warning, and you have the values there too to help out. Very important to look at some of those things. So this is the potential storm surge flooding map. It's really important to look at this because that's the most dangerous part of these hurricanes. So this had social science going into it. The next one, we'll see some more. A lot of debate. You get the scientists in a room, they'll have a debate about this stuff. But what people really want, what we heard in the social science, and it makes sense, is when we talk about flooding, how much water is in my house? How much water is up my pant leg? That's how you describe it. And they don't have to convert all the datums. They don't have to convert everything. This is the way they want it. And that's why we try to show it this way based on social science. The next one, just wanted to pass on a few of these. Dr. Laura Myers did some research, and this was after Michael, and asked the question, really looking at, what makes you want to leave or not leave? What are you looking at? And it's pretty interesting to get the data because it supports the work we have to do with social science. And these were the top four. These were the top four answers. The top one, past experience. In other words, I'm making my decision based on what's happened in the past. And I can tell you, I guess, 27 years of doing this and, talking to a lot of people along the way, people base their risk on their past experience. And the problem is every storm is different. Just because it didn't happen last time doesn't mean it can't happen next time. Those are very, very important things to really consider. So past experience, not always the best thing to use here. Listen to those impacts. Every one of these is different. You hear things like they always turn and things like that. Well, they might have in the past, but it doesn't mean the next one will. Track, forecast, or the cone. So we're still very focused on that track, so focused on that cone. We have a lot of work to do to keep telling people in shows like this and getting out there and telling people we have a lot of impacts outside that cone. And that's why we've got more work to do with that. The storm intensity goes back to Justa. And I can tell you there will never be a Hurricane Justa. As Bill, and the World Meteorological Organization, we have something to do with the names, and we're not going to have a Justa. I guarantee you that, not on my watch. So we got to watch this one because people still focus on the intensity. And you have a storm that goes from I'll use a real example, Florence, going from a Cat 4 to a Cat 2 and eventually 1. That's not time to let your guard down. It's still a large storm. And actually, it's interesting that the storm surge forecast and the rainfall forecast, neither one of those things changed at all based on the wind weakening with that storm. And we don't even like to use the word weakening. We just say the winds have gone from this to this because we don't want to take away from those impacts. So you can see how the social science plays in here. And the last one's the actual hurricane warning. Remember, that's tied to the wind. So there's other things. There's more work that we have to do. And I'll show you what we're doing about this in a little bit. The next one, I just wanted to share some other research. I think I shared this with everybody before, but I think it's still important, this Yale University study that went out. This is what we deal with when it comes to putting out the information and what the decision makers have to deal with when it comes to evacuation. I'll just cover the top, middle, and bottom. There's a group of people that are the first out. I mean, you have the first storm out there, they're gone. They're out of here. You have some that, well, it didn't happen last time. We're going to wait. I want to wait and see if it turns. I'm going to wait a little longer. And there's also some that won't leave. They have other constraints. They just can't leave whatsoever. They have economic reasons and a lot of other reasons they can't leave. This is who we're dealing with, and everybody fits into these categories. There's a lot of barriers to evacuation. So those are the studies that we like to look at to help with the messaging, and we spend so much much time on key messaging to really help communicate those risks. I think that's a really important one. And the next couple are just a couple quotes. I won't spend too much time on them. Public perception is everything. And here's just some examples. You can read through them. I don't have to read through them all. I live 100 miles from the coast. I didn't expect this. Well, a tropical system is not just coastal. You can have impacts well inland. Didn't happen before. I'm fine. You can see all the quotes that we have over time. I like the other one, the middle one too. I thought these floods came once in 100 years. You hear people talk about the 100-year storm. I just want to really talk about that because that's a 1% chance of having flooding. That doesn't sound like much. I mean, you think about 1% chance. That's not that much, but that's 1% chance every year. Every point's got another 1% chance. That's also 1 in 100 chance every year. That doesn't sound like much, but if I change those numbers to, it's around 26% chance of flooding in your 30-year mortgage, that's got your attention. And by the way, all those were saying the same thing. The next slide, I got a few more quotes here. I won't cover them too much. The one I want to cover really is the bottom one. This is an important one, and we actually have a study going on looking at this one. The forecast changes. Things change. It gets updated. Remember we talked about the errors in the further out period. It was nothing when I looked a few days ago. Well, things changed, and things could rapidly change. So this is called anchoring. It's a social science term called anchoring. There's a tendency to look at the forecast and then make your decisions based on it and not look again. So really, we all have to work together to really communicate, keep looking at those updates. Things change, and we have to really be mindful of that. So lesson 5, we're halfway there. Intensity forecast is tough. We're getting better. These are the charts. We're always very open, again, with what's going well and what's not. The intensity forecast is still difficult for us, and if you can look through time, we're getting better. So at least there's a slope that we're headed in the right direction here, but still very tough. And if you look at this last year, the second largest annual error at the day 5, mostly because of Dorian, and I'm going to show you why. It's really interesting. The next slide. Really dive into this a little bit here that I think you'll be interested in. So this really helps out here. This is looking at the intensity errors, kind of like the other one. You look over the decades. We are getting better. It's not as much and more striking as the actual forecast for track, but it is getting better, so that's a good thing. So let's examine it a little bit. Got some studies here that I think will be pretty interesting for you. Here's the track forecast with Florence. We already showed it to you, but don't have to push that along. So track forecast, good. The next slide looks at intensity. We struggled with the intensity. If you look in there, you can see the red dashed line. That's actually what happened. That was the intensity in Florence. So a little behind the power curve with the rapid intensification at the beginning. And once it got going, there was an eyewall replacement, and Florence didn't recover. And we over forecast the intensity on the other end. Intensity is tough. There's still so much more about the oceans, the upper atmosphere. NOAA's working with the Navy, dropping gliders into the ocean, trying to get the water temperature profile, not just the sensor at the surface, but are we turning up warm water? Are we turning up cold water? There's a lot more science that we have to utilize here. So if you, all the students out there, if you happen to be watching, these are some opportunities. Whenever you see these opportunities, there's opportunity to research, there's opportunity to make the forecast better. So that's an example there. I did want to show Michael, same thing, pretty consistent. Track forecast, pretty close together. Those are all our forecast tracks. Underneath there, you can see the white line. That's actually what Michael did. The blue is our forecast. Not bad, not bad. But the next one, we'll look at the actual intensity. Same thing. Really, here we're really looking at our forecast. You can, in the white line there is what Michael did. You can see the NHC forecast with the arrow there. It's the top one, closest to what actually happened, and the models are all underneath. And that rapid intensification, the models weren't forecasting it. We edged in that direction, but it rapidly intensified beyond the forecast and beyond what the models had there. So there's more to learn in these things. So I just wanted to point some of that stuff out. The other one that's interesting, here's a takeaway. That I think is interesting. If you look at our data, we actually do a better job at the forecast with stronger storms. And you get these hybrid storms, these half storms, you get the structures strange and all this. They're tougher to forecast. They're tougher to figure out what the steering currents are. They're really tough to figure out what they're going to do. So just an interesting look at history here. If it's less than 50 knots, the green, we have more error. If it's greater than 95 knots, a stronger storm, we actually do better historically with the forecast. So just something to keep in mind. I mentioned Dorian, and we're going to look at that. And I had it in the intensity lesson, but then I took it out and made it its own lesson because I think it's a good case study. This is a big one for me as well. Lesson 6, lots of potential error in the genesis phase. In other words, when storms first try to form, they can have incredible amount of error associated with it. The models don't know what center to track. We may not even have a center. We may have multiple centers. There's all sorts of things that could come to play here. So let's look at Dorian because it really shows this really well. The short-term forecast track is very difficult. Dorian's had multiple centers. I remember the plane going into Dorian early on and finding 3 centers, and everybody thinks about how important the hurricane hunters are, in these well-developed storms. That's when the best pictures are, into the eye and seeing the stadium effect. It is incredibly important that we have hurricane hunters even early on to really get out there during the genesis phase, formation phase, to see where the center is, which center is going to be the strongest, which one's going to take hold. It makes a big difference in the forecast. So as a result, I want to show you what happened here. Let's go to the next one, Dan. I think it really starts showing this. The difficulty in Dorian's intensity forecast, there was 100-knot error in day 5 in the intensity forecast. The models didn't even have a hurricane, and I'm going to show you why. The next slide, all the model tracks basically took Dorian over land, over Hispaniola. And if you know the terrain, those large mountains, just massive mountains. So the models took the system over, these high elevation terrains, ripping the storm apart. And that's what the solution was, which is pretty interesting. You can see the model tracks versus the actual track there. And we know the damage. You're good, Dan, on the next one. You can see the damage. It just an amazing amount of damage in the Bahamas. Abaco Island on September 1st, nearly stationary for more than 24 hours, just absolutely catastrophic in the Bahamas. I got to look through some of those areas and talk to a lot of people there about 3 or 4 months ago. Just the devastation's just terrible. So the next slide, you're going to see some of these scenarios that happen. So with time, of course, we know the Bahamas, impacts in the United States, coastal impacts in the Carolinas, as a Cat 1. But look at the next one. It's interesting to look at Canada. Power outages, just an amazing amount of power outages. And Nova Scotia, 80% power loss there. So big impact type of storm. So the next one, I wanted to go back to that genesis phase. That's what we're looking at. So, okay, yep, we're keying in on this. We're saying we can have development. The models are looking at it. They're making a forecast track. Let's do 3 scenarios with Dorian. The next one, I want to show you this. So if you look at it, you can kind of see the loop there is interesting. So scenario 1, Dorian moves basically where the models have it. Really, it comes in contact with Hispaniola. And if you look at the actual impact of this one, significant disruption. I mean, dissipation. I mean, in this case, shredded. I don't know what would have been left on the other side. Probably in the end, maybe some rain for Cuba, maybe some rain for Florida. Probably not a whole lot of development. It would have been tough to recover after being completely shredded. So that's scenario 1. Scenario 2, Dorian moves near the official forecast, kind of splitting the difference. With interaction with Puerto Rico, Hispaniola, we were doing briefings for Puerto Rico, thinking about some impacts there. Would have been some weakening, but there would have been time for some re-strengthening. But in the end, probably would have moved a faster scenario, would have impacted Florida more and quicker. And so it would have been a completely different situation in the extended forecast. Let's look at the last scenario. Well, this is one that happened. We had a situation where the hurricane hunters found out the right center was the one that took hold. So you had a center jump over to the right-hand side, and you started getting this scenario where we moved, with the cone, but a lot of water, a lot of warm water, not a lot of land to interact with. So really intensification of this hurricane. But the other factor here that I think is really important is the fact that that scenario there was longer, and then the steering currents, the high pressure moved out, and that allowed the stall. Every one of those scenarios had a completely different outcome. During that genesis phase, I can't describe how difficult that forecast is, and you can get a lot of different outcomes from this. The next one shows, despite those challenges, the NHC forecast, track errors for Dorian, that's not bad. Day 5, 87 miles. You can see at day 1, 16 miles. The forecast was still on track, despite it being a very difficult forecast the entire way. I did want to show the next two that are kind of interesting. When I gave a talk in the Bahamas, and I was able to show this with a center point over some of the Bahamas. 1990, that would have been the cone. Think about this for a second. Take this one in. That would have been your cone in 1990. The next one, that's your cone today. And I think that's an interesting look at history. Why does that matter? The next two slides really explain why that matters and how far we've come since Floyd. I think this is pretty interesting. You look at the track of Floyd. This was in 1999. Not too much different than Dorian, right? Not too much different. But in Floyd, 2.6 million people, evacuated from 5 states. At the time, it was the largest U.S. evacuation in history, from South Florida through the Carolinas. Huge evacuation. And the next one shows how far we've come and why it matters to do better. Not too different, right? Not too different in the actual forecast, but in this case, your average 3-day error, 35 nautical miles during this, and you didn't have watches and warnings for South Florida. In fact, in this case, it's preliminary. We're still looking at it. As many as 3 million people did not have to evacuate in Dorian that might have back in Floyd. So it does matter in making this forecast a lot better. And the next one is just another illustration. Just another one to show the 1999 cone and the 2019 cone. Difference in the 3-day track error makes a big difference. Okay, so the next one, everybody's been hearing me say this. When you close your eyes, what do you see when you think of a hurricane? A lot of us are really into weather, and I think we can see all the impacts, but when you go to a lot of communities and talk to people, they see the wind. In reality, it's the water. Storm surge accounting for half the fatalities, rain 27%, 90% of fatalities is water. We got to keep having this conversation. So lesson 7 is water is what kills, and that's what we have to keep talking about. Let's go through some of these to start really peeling things out a little bit. So if you go back 2016 to 2018, 83% of the fatalities in those tropical systems in those years was water. What's interesting is that also corresponds to the debut of the storm surge watch and warning in the inundation map. It may have made a big difference here, and we'll have to see what history says going into the future. We'll have to add, every storm to it to see if it's really made a difference. Remember, the storm surge has been half your fatalities, the leading cause. Different in 2016 and 2018, 83% water related. Most of those inland flooding, only 4% of those were storm surge related. But the next one is something we all have to work on together. During the past, seasons, we start looking at those fatalities. We talked about 83% being that inland water. Half of those were in automobiles. We have to keep spreading the word. Not to drive your car where water covers the road. The whole turn around, don't drown slogan that we've had for years. So we just look at the data and try to share that with everybody, what's going on. So it's the water that kills. The next one you can see, just some examples, then I'll move on from this one. Just from last year, Barry's swath of heavy rain. It's kind of an interesting one that starts off with basically a storm in the Midwest. It makes a big loop into the Gulf, very well forecast, but kind of half a storm. And the front part of the storm didn't produce a lot of rain. The backside did, 20 to 25 inches in some areas over Louisiana. But if it could have doubled, easily doubled, if that storm was more symmetric. So just interesting to look at. The next one here is interesting as well. These rainfall events. I mean, you get a slow storm. It doesn't matter if it's named or not. Anything slow is going to produce an incredible amount of rainfall, as we have here. 44 inches of rain, 4th wettest tropical cyclone in Texas history, 5th wettest in the United States. Look, and I think one advisory from Dan. Actually, Dan did the advisory on this. So you had another year with a major rainfall event, and I wanted to show this because the next one shows the history, and it's another rainfall event, on the heels of other ones that we had. I mean, you had Harvey, Florence, Lane in Hawaii, just some record-breaking rainfall events, and that continues to happen. It seems like each season we're getting another one of these. So again, it's about water, not just on the coast, but well inland as well. So we have forecasts for it. I wanted to share the Hurricane Florence forecast real quick. If we could get the track right, and we could get the size right, and we get the speed right, we can get the rainfall right. They all correlate together. On the left is the 5-day rainfall forecast. forecast at 5 days. And on the right is the observed. Not bad. Okay, so we're doing pretty good with these. That's the Weather Prediction Center up in College Park does those forecasts. And here at the Hurricane Center doing the storm surge forecast on the next one. This one is not just a point to look at when it comes to the accuracy of the forecast. You can see the forecast on the actual left, and on the right's what happened. That's not necessary, just the point. The point is those highest levels right there in red. That was about 100 miles inland. You start looking at New Bern, you start looking at these rivers and these inlets. What an example that you all can take this slide and show people that it's not just on the coast, it's well inland as well. That's storm surge. That's not even adding in the rainfall associated with that. Okay, so the next one's lesson 8, getting close here. This is an important one that we got to keep talking about, because you know, lesson 8 is, it is, I was going to say ain't, I probably should have. It isn't over till it's over. There's so much thought out there that says, well, the storm's past me now I'm safe. Some of the residuals from these storms can last for weeks, if not longer. You look at the next slide, you know, you start looking at indirect fatalities, the longer term impacts. And I'm not talking about, you know, just, you know, looking at the storm surge or looking at the rain, looking at the wind. Those are the direct fatalities, but the indirect, in this case, the leading cause of some of these indirect fatalities is cardiovascular, is heart attack. It's heart attacks not only at home, but it's also in the evacuation. You can see the other causes there, from power to car wrecks. There's a lot there, but health stands out as a big one on here. And speaking of that, I wanted to share this. This is new. That we've put together for this season, just to kind of indicate the vulnerable population. We've got to have more conversations about working with the vulnerable population and you know, getting the information out there about their risk. And here's an interesting data point that, based on Ed Rappaport's research over the years going back in time, 8 times as many victims over the age of 60 as under 21 years old. In other words, you know, you start looking at the risk population and who's losing their lives in these tropical systems. This is the data that we have to look at to help each other out. One of the Hurricane Awareness Weekdays, we talk about helping the neighbor and helping the neighbors, and I think it's a big one, and that's one way to do it. And if you look at the leading cause of fatalities with those over 60, cardiovascular, evacuation, and you can see some of the other causes there, but health remains the number one issue with those. So I think it's an important point to be able to draw this out and actually look at it. And actually looking at the indirect association with fatalities and the evacuation part of it, this is during the evacuation. This is an evacuation associated. The older, it's tougher. It's tougher the older you get on some of these evacuations. So definitely want to get that word out there. So lesson 9, storms don't care about your timeline. They really don't. And I've seen this so many times over the last couple of decades. This is Florence. You got 10 days plus. You got plenty of time. In fact, I was getting emails about, well, is it going to get here? All right, already. Let's bring it on. This is taking too long. Some of them are like this. The next one is not so. Michael, you know, Florence was 10 days, Michael, 3 to 4 days. So the reason I want to put this up here is because storms don't care about your timeline. It's so important that you exercise and shorten that timeline and practice it. And this is a stat that I used last year for the first time. I want to do it again because it's important. You asked the question, where were the nation's most powerful hurricanes 3 days prior to landfall? This takes the Cat 5s. This takes all 4 of the Cat 5 landfalls in the United States. And you start looking at history. You got the Labor Day storm, 1935. You got Camille in 1969. You got Andrew in 92, and Michael just a few years back. It's really interesting to say this, that each one of those Cat 5 landfalls, the ones that we have on record in the continental United States, were basically tropical storms 3 days prior. So they're all rapid intensification situations. They all strengthen quickly. So once again, so critical that we exercise our timelines, shorten them up. I think there's one more in the series, Dan, and it really shows the little stat here that says, you know, they all rapidly strengthen. They happen fast. We got to be ready. You got to be ready to shorten your business timeline, all your timelines, even your personal timeline. Be able to have those executed pretty quickly because it can happen really fast. So let's go to lesson 10. This is one that I'm still working on, but there's probably more information associated with this. But you got a message in many ways, and I think it's within even my own family how my my daughters get information so differently than I get information, and I get information so differently than my mom. You got to message in a lot of different ways, and we're taking to the web, we're taking to social media, we're doing everything we can to get the information out there, because the people we're trying to serve and save lives with our mission, they're getting information in different ways. So I think it's really important to think about this as we go into the future. The next one really shows some of this as well. We're spending so much time on the key messages. I can tell you that behind the scenes, we agonize over every word in those key messages. I bet 3 people, Dan knows, somebody will write them, Dan will look at them, I'll look at them, everybody looks at them before they go out to make sure we get the words right, because words matter. Every word matters, and you want to get the right message out. So we really are trying to use social media to do that. Changes, and then I'll wrap this up. Changes for 2020, I just put some that I think you'll be most interested in. We have those storm surge watches and warnings for Puerto Rico and the U.S. Virgin Islands. Really excited about that. No inundation graphic yet. We're working on those. And we have an experimental peak storm surge forecast graphic. This is brand new for this year. It's experimental. And, you know, it's one of these graphics that we need, just a big picture, easy to share on social media, easy for a briefing. It's a quick look at the storm surge values, and you can always dive in and get the inundation and get more details. But real quick, you can see, wow, what are the hot spots here? So we have that brand new for this year that I think everybody will like. And the next one, you're going to see a new dot on the map. We added a 60-hour point, and there's the new dot right there. Why is this important? Well, it's not just a dot for us. It also gives us the wind radii. It gives us the size of the storm. And I've mentioned in this presentation, it's the size and speed of the storm that have a lot to do with the storm surge. That point's going to help us with the calculation of storm surge as we try to go further out in time for everybody to give the greatest heads up that we can. So you're going to see a dot on the map. We had a lot of requests for that, so that's going to be brand new this year as well. So that's good. And what's next? We're continuing to expand the storm surge model improvements. We're putting waves into storm surge with the forecast, which I think is a big plus. If you think about the storm surge forecast, those values don't include waves. So we actually, when we go do the surveys, you see the storm surge, you see waves on top of that. We're trying to get that into the forecast. And we've got Southern California. You think about it, yeah, they can have a storm. So we've got storm surge forecast that we can do for Southern California. We've got new basins that we're moving out. So that's exciting. And expansion. Dominican Republic and Haiti, remember the beginning? We talked about how large of an area that we cover. We've got those done. Yucatan, Belize, 2021, Bahamas. A project will be starting, should be completed 23, 24, and our vision is to keep expanding that with time. So very excited about that project. And I think this is going to be the last one before the thank you slide is social science. This is proof that it's really important to us. We've got some big projects going on right now. We're looking at the cone. We're looking at economic values of the forecast. We're looking at our website. We're looking at how people interpret the information that we have, and also percentages. You know, you think about a 20% chance doesn't mean a whole lot when you think about an afternoon in the summertime in the South. A 20% chance of rain doesn't mean much, but a 20% chance of a 10-foot storm surge, that means something. So we're looking at some of those percentages and how we can share some of that information. So I will share, when we get this data back over the next couple of years, I'll share that with everybody that's watching here today. We'll make sure to share some of that data and our plan, what we're planning to do with it. So the last one is just thank you. Thank everybody for watching. Bill, Tim, Alex, Dan, thanks for running this thing, running my slides. I thank everybody for being a big partner in this. We can't do it alone. You know, you can tell, you know, any one of these hurricanes, media, emergency management, it's a partnership. That's the only way we can get through these and save lives. So I want to thank everybody for the partnership, and I hope this was useful, and that's all I got. I'll be quiet now.
Ken, that was a terrific presentation. I can hear the applause coming in on the wind here at South Padre Island right now. We appreciate that. Let me share a couple of the comments that came in during the Facebook feed, and then I know Bill is going to have some questions as well. Rich Johnson's first comment was he remembers that John Hope didn't appreciate it when anybody referred to storms as fish storms at the Weather Channel back in the day. And the late, great John Hope. He also said that one of the problems he fears most is when media and internet meteorologists jump on that first model that still doesn't have an idea where the center is, and they go with that and they run with that, and they put that all over social media and say, look, here it comes. And that's one of his fears. And you've talked a little bit about finding that center at the beginning being an issue.
Yeah, it really did. And I think that's an important one to look at, because I think the more we can share some of these lessons, and there's probably more. I'd love to hear from other people and what their experiences over the years as well, and see if we can keep building on this. But the biggest thing is, let's share this stuff. Let's talk about this stuff. That way, there's study after study that says a consistent message leads to a better response and decisions by the public. And if we can stay more consistent and all be on the same page, we can make a big difference in saving lives.
Barry Goldsmith has commented on how really Allison and Imelda and Harvey were just tropical storms when they did a lot of their flooding damage. And so, hashtag more to the story than the category. And that's something you emphasize as well. And I think that's a good point, that some of the biggest floods we've seen in the recent years have not been from hurricanes. They've been from remnant hurricanes or tropical storms.
Yeah, shout out to Barry. Thanks for that, because he and I've talked about it over the years too. So yeah, it's true. I mean, it's these. Look, and it's interesting. It's not just the category. A large storm. Think about this. A large, slow storm can produce 12 foot of storm surge depending on where you are on the coast. I mean, that could be a category 1. That could be a tropical storm. I could build a tropical storm that's large enough and slow enough to produce a 12-foot storm surge. That's something to think about for a second. And so it makes a big difference. You're going to have a category 4 or 5, and it can produce devastating storm surge, of course. But if it's small, that area is pretty contained. And so that's why it's so important to pay attention to these impacts. It's just, we can't talk about that part of this enough.
Barry also makes a comment about, you mentioned the older people being more vulnerable. And what about those with underlying health conditions and the other issues that really make it challenging to get them out to begin with?
Yeah, I think it goes back to this comment about the vulnerable population, helping thy neighbor type of thing. It is, you gotta, there's different things that go on. I mean, there's also economic factors as well. So it's not just health, it's not just age. After Florence, meeting a group of people, multiple families that live in a very small home, didn't have the economic means. So that's another one that we have to look at, and making sure that we pay attention to those that need this and the vulnerable population. If those truly are the ones with the majority losing their lives, we can spend more time talking about it, presentations like this, and then actively trying to help them out.
Let me bring Bill back into the conversation. Bill, you sat in that office for a while. Go ahead and unmute, because I know you've got a question or two you want to ask.
Oh, I could have millions, but I think I'll focus first on one of your last points, the messaging. I know your operations are going to be highly different this year. You probably won't have media in the building. How do you think you're going to do the media outreach for landfalling storms this year?
Yeah, the game plan, Bill, is we're still going to have the media pool in English and Spanish. So we're still going to be able to reach, all the local stations, the national stations in English and Spanish. We're still going to be full speed ahead on when it comes to being able to do the media interviews. That's not going to change whatsoever. And it's interesting. We're actually socially distancing to make sure that we can do that safely. So there's even, if you come by and see us, Bill, we've even got tape on the floor to make sure that we stay where we're supposed to be. But we plan on doing that just like we always do.
Excellent. That's good to know. And I think there'll be just our experience in the work from home mode that we've been in a couple of months. I think you're going to see an even greater expansion of the use of social media from you guys and from people that interact with you.
Yeah, and it's interesting. We've talked about that. And we've talked about another fact, Bill, that's kind of interesting I wanted to share. We've had conversation that even the decision support is probably going to be greater than ever. So we're planning on being able to make sure we have enough of people to be able to do the briefings and be able to not just do the forecast, but be able to explain that forecast and explain the nuances of the forecast. So yeah, I agree. I think the social media greater than ever. And I like the fact that, look what we're doing today. Look at this show. Look at the reach that we have with this. How amazing is this? We'd love to be face to face, but since we can't be, at least we're being able to do this virtually, and we can still get the word out.
That's exactly right. Thinking back on the slide you had with some of the verification we had some questions on the Hurricane Forecast Improvement Program. At what point will we reach a plateau? Have you heard any discussion that on especially the short range, say 24 to 48 hour time frame, the track forecast, we might be approaching a plateau on skill for that?
Yeah, I've seen some of the studies, and I think we're still getting better and better. But I think there's going to be, a point, and again, I don't have this thought totally flushed out, But I think at some point, we'll continue to track, the forecast area when it comes to the track, but we still have all that work with intensity. So there's still that we have to spend some time improving that and understanding this rapid intensification science mystery that occurs. I mean, eyewall replacement in Florence, but then not keeping that strength afterwards. What was that? So there's a lot of that. I think the other part here is even if there is some sort of plateau, you may see some bouncing back and forth. That gives us a lot of opportunity to say, okay, we've got the track, it's a good track. Let's spend time on those impacts. Let's spend time perfecting, the storm surge, the rainfall forecast. How about size? The bigger the storm, we've got to get that right, because that has such a huge factor in the storm surge, the wind field, where the rain is. A large storm, I've seen rain bands 200 miles away, and some of the highest values of the rainfall and almost all your tornadoes are in that rain band 200 miles away. I think the way I'm looking at this is, even if we are plateaued, maybe we can make a little difference if it's not plateaued, but we got a lot of work to do. We got still all these other parameters that we got to spend more time on.
Sounds good. Maybe a lesson number 11 I can throw back at you from old times' sake. 30 years ago, we gave you a 2-day forecast and you were begging us for 3. We finally got a 3. You started begging us for 5. We got 5, and it wasn't 2 years later, you were begging us for 7. So if you get there and you get 7, they're going to be begging you for 10.
Yeah, that's right. And it's interesting because we're doing that internal day 6 and 7 forecast. We're looking at it, but the Florence example is fascinating because at day 6 and 7, when you see a recurvature into the Atlantic, then you get into the social science of anchoring. If somebody sees that 6 and 7 day forecast recurving and they go to the fish camp and they go to the hunting camp and over the weekend and don't look again, they're going to get a big surprise the next week. So we're trying to think about how do we show that? Should that be part of the cone? Should that be something different? We're having those discussions. I hope that social science can really help us out with some of that.
It is a big challenge. If you recall, in Hurricane Ike, one of the early, probably a 72 to 96-hour time frame, there was a forecast in there that it had inched farther down the coast towards the lower valley, and the state of Texas Emergency Management was ready to pull the plug and move all the buses for the major evacuation down there because they needed so many. And it was just luck that someone convinced them that they ought to wait a couple of forecasts. They'll have enough time. Otherwise, you end up with all your resources in the wrong place.
Bill, you mentioned Ike. I want to mention 2 things that just stand out for me and Ike. I was working at the Slidell office, and one thing that's interesting, Gustav was a direct hit on Louisiana, and Ike stayed offshore and went over to Texas, but you had more storm surge in Louisiana and Ike than the direct landfall of Gustav. Interesting, right? So, impacts matter. The other one that sticks out to me is how early that storm surge arrived in, Galveston and other places before the center. So that's something else. That's something we didn't even talk about in this presentation, was timing. Those large storms can push that storm surge out well before the winds. That's a whole nother conversation that we can talk about.
Yeah, the track parallel coast and all, that's something else.
Bill and Ken, let me jump in with some of the questions from the Facebook feed. You've got a bunch of them coming in, and we appreciate everybody. Gregory Thompson from the Bahamas is asking, do you anticipate doing a peak storm surge graphic for the Bahamas sometime soon? He says, we remember Dorian.
Yeah, we'll always, remember Dorian, and we think about the Bahamas all the time, and everybody went through so much with Dorian, and the answer is, yeah, we're working it. And that one slide that I showed, when you start looking at, I think it's what's next in storm surge, you can see right on there, we're going to be doing that. We're actually starting a project. I hope to be done in 2023, 2024. So much goes into it. You have to know elevation, you have to know bathymetry, how the shape of underneath the water is in the ocean. You have to know the shape of the coastline, where the water piles up. There's so much information that goes into making a storm surge forecast. We're collecting the data. We're working that project. I hope by 23, 24, we're going to have storm surge projects for the products for the Bahamas. We're really excited to be able to do that. And remember, this is interesting. We've only been doing the storm surge forecast for the continental United States. This is all new. We've only been doing that for a couple years. So we plan on expanding it. It's important. It's the leading cause of fatalities, and it's important to us to keep expanding.
Yeah, I hope that answers your question. That's great information. Marcel Ligabo wants to know what's the future with social science related to hurricanes, a better use of social media or studies related to evacuation.
Yeah, I think it's the studies. I think if you think about it, I didn't even list all the social science projects we have going on. We actually have a total of 9 social science projects going on at the same time because, if you think about it, I go back to the same comment I made before. You can see the science improvements, even intensity. We're still better than we used to be. So the physical science, through years of research into operations, is getting so much better. But the social science is a big part of it. You can have a perfect forecast. If it's not understood or actionable, there's still a missing link there. So we're going to collect the data. It's huge. Social media is just part of that and the communication strategy that we have. But we got to have the data. Is the forecast understood? Is the shrinking of the cone? I showed in this presentation that's a good thing. But at the same time, the counter to that means more impacts outside the cone, right? So how is that understood? Or do we need to look at different ways to portray some of that? So that's the data that we're looking for. I don't want to make any big decisions in our products. I don't want to make any big decisions on categories or cones until we get that data, because we just don't want to make anything worse. We're trying to get better.
Michael Phillips is asking a couple of questions. His first is about Chris Brenchley from the Central Pacific Hurricane Center. They're unveiling their seasonal outlook today. But he said last year they sent resources from Hawaii to the mainland to help with the 2019 hurricane season. In light of COVID, how are you going to be with resources, and how will the shared resources work with backup offices in the event of multiple threats or a threat into Miami?
Yeah, I think it's interesting. The weather forecast offices have their primary backup, their secondary backup, a tertiary backup. So all that's accounted for. We get the centers. If you think about the Hurricane Center, we have the Weather Prediction Center helps us back up the hurricane part of it. The Tropical Analysis Forecast Branch, the group I was talking about with marine forecasting, the Ocean Prediction Center backs us up in College Park. And the other part of it, so we have our backups, but the other story is, we're doing things here. I alluded to it a little bit earlier, but we're social distancing. We're taking precautions here in the building. We're doing everything we can here to keep ourselves safe, because let's face it, everyone depends on us every hurricane season, and they're going to depend on us more than ever this season. So as a matter of fact, we're keeping ourselves safe so we can make sure we continue with the mission. And we fully expect we're going to provide all those watches and warnings, forecasts like we do every single year. We're going to have our mission this year just like we always do.
One last question from the web. This is also from Michael Phillips. He says, this year the Hurricane Center had student webinars for 4th, 5th, and 6th graders that appear to be been well received. Any additional thoughts on content products geared for younger people in the months and years ahead?
Yeah, we're so excited about that. And it's interesting, the fact that I've got it written on one of my sticky notes here. We had some international kids on the call yesterday. And Dan, you were really excited about it. They were asking questions and really interactive. Yeah, we plan on. I think it's a best practice. We want to keep doing that. We used to try to do it on the Hurricane Awareness Tour. This year we had to do it a little more remote from the office and at home, and we're able to do it. I think we need to expand it. I think we need to reach the young folks earlier. How much, all my presentation, you saw opportunity for improvement. So I go back to those hurricanes at home. I go back to this presentation for the young people watching, spread the word. There's a lot of room for science. We need you. We need you to come into meteorology and oceanography and all the sciences to help us out. So we want to continue to do that. I think it's so important.
That's terrific. Let me go back to Bill for some final thoughts before we wrap up. Bill?
I have no more questions. Let's hope you have another 2010. Lots of storms, but they all stay at sea.
Don't call those fish storms.
No, not me.
Gentlemen, thank you. Ken, we really appreciate you taking time to be with us today. Fascinating presentation, a lot of great information that we all can use. And of course, this is live on Facebook and a number of other platforms as well, but it's also being archived so people can watch this at any time. So we think this information will continue to get out. So Ken, thank you for spending time with us today. We sincerely appreciate it.
Absolutely. Thank you all for doing this. You're a big part of the team. Thank you for being part of the mission. We're all in this together, so it's really appreciated.
And thanks, Bill, also, because, Bill, you really add a lot to the program. Having sat in that hot seat for a few years yourself, you really add to the give and take. So we appreciate that, Bill.
Oh, my pleasure.
Alex, any final thoughts?
Oh, absolutely. Yes. Thanks for being out there in the wind today, Tim. It was pretty good for you to see out there. I want to remind everybody, we've got a lot more programs to go all during the month of May. On the 21st, which is tomorrow, we're talking with the Hurricane Hunters. That's Lieutenant Colonel Ryan Rickard and I believe it's Captain Garrett Black as well. They'll be telling us about their flight through Dorian. Then, if you really want to get the ground zero on Dorian, you got to join us on the 26th of May. We're going to be talking with Josh Morgaman, High Cyclone, the Hurricane Man himself. That's also at 10 o'clock CDT. All these programs are Central Daylight Time. Coming up on the 27th, we're talking with Jeff Huffman. He's going to be telling us about the latest research he's got there about media trust. And then we'll be talking to Sean Sublette from Climate Central, how hurricanes and climate have worked together. That's on May the 28th. Again, all the programs, Central Daylight Time. Thanks so much for being with us. Please share this out with your friends. We'll have a rebroadcast of this program tonight at 7 p.m.